Hi, I'm Nimim.
Hi, I am Selma Gouza.
Hello, I am Muad.
Hi, I'm Amin Screen.
Hi, I'm Shayma Asfrab.
I'm Omar MOUSTAHIB. Basically, the components are buttons for light manipulation, distanced by 1 meter from each other. Here we have the Raspberry Pi connected to our RFID card scanner. Of course, we have the LEDs controlled by the Raspberry Pi GPIO outputs and connected to the breadboard with the resistance.
Node-RED is a flow-based development tool for wiring together hardware devices, APIs, and online services as part of the Internet of Things. Node-RED provides us with a flow. In the flow, we find the map of all the components. These cases are the link between the Raspberry Pi and the web server. For example, let's check this box here. Here we can see the query that selects data from the database. In the next box, we see a connection to the database. And in this set global info box, we can see that it's an if-else statement. Either the user is there or not.
We have used Node-RED for our web server and Mosquero, a message broker that implements the MQTT protocols. We receive the topics from the Raspberry Pi. Each component sends its own data. For example, the RFID component scans the data from the card, and this data is sent through the broker to the server. The server checks if this data is available in its database. If it's the case, a welcome message is announced, and you can access to the platform to start the exercise.
In the digital image processing part, we have implemented a system using OpenCV and DLive technologies for both fatigue and pain recognition of the patient. The system is going to detect from one part the patient's eye dilation and also from another part based on whether or not the patient is yawning. As for the pain recognition, the system is as well going to take into consideration the eye squeezing of the patient to deduce the presence or the absence of pain.
Node-RED provides us with this beautiful UI interface, where we can see all the components that were built in the node map. Here, for example, we can see the 4 LEDs. When the program runs, the LEDs take different colors depending on the LED true color. And here we have a message that tells the level and the game score.
Here, for example, let's take healthy person case. Of course, a healthy patient will pass the test easily. At least, he will pass the first test and the second one. The first level has 80 seconds as maximum time. After that, the program stops. If the patient succeeded, he will pass to the next level. Where the time is less, the LED's pattern is less complicated.
After completing the test, we can see that the new values have changed. And also, if we check and refresh the database, we will find that the new data is there. So that the next time the user enters again, he will be remembered with his last score and level. To see how the levels functions, we are going to restart the program again, but this time we are going to press only few buttons during the test, and we're gonna let the LEDs switches by default after 5 seconds. Here we can see that the data has changed. And for the database, let's check the new level. So when the user scans his card again, he can see that he is in the low level, which means that the patient needs more treatment.